Alright guys, a quick little video on hyperbolas. So I've kind of been alluding to what a hyperbola looks like, and it's almost kind of like an ellipse, but instead of the two pieces coming inward like that, they're turned outward. And one thing you need to pay close attention to, there's a minus sign in the middle. There's a minus sign in the middle. Okay, that's really important. That's one way. It looks just like an ellipse except without a plus sign. Minus sign in the middle. Okay, and then the other thing you need to realize, and what's the thing we look for? Like in a parabola, we look for the not squared letter. An ellipse, we look for the bigger denominator. For a hyperbola, we look at which letter is in front of the minus sign, or which letter is positive. Which letter is positive? And that's the letter that tells us which way the hyperbola goes. If y is the positive letter, it's an up-down. See, y in front, y way. X in front, x way. Vertex is the same, or center is the same, hk. The other thing, though, you need to kind of keep separate with the hyperbola is we don't really have co-vertices. We only have vertices. We don't have co-vertices. We have a focus, just like all the other ones have a focus. It does have a new formula. It is different from an ellipse, and it does look like Pythagorean theorem. It is the Pythagorean theorem. The way I kind of help myself remember this is hyperbolas are the ones with the minus sign, but the focus formula has a plus. And the ellipse is the plus sign in the formula, but the focus formula has a minus. So I just remember it has opposite signs. And then there's something new with hyperbolas. We don't have co-vertices, but we do have asymptotes. And we're going to have to write the equations of those asymptotes. That's probably the hardest part with a hyperbola. Just remember that your asymptote has to go through the center and has a rise over run slope. And the rise and the run are those same a squared, b squared, those a and b letters. And I'll talk about that in just 1 minute. So, looking at the first example here, I want you to notice, first of all, that y is in front of the minus sign. So this opens up, down, or vertically, because y is positive, or y is in front. Now, the center is 0, 0, but one common mistake, watch out for this, is let's say they had some numbers subtracted here. If it was like y plus 2 squared minus x minus 1 squared, or whatever. I'm going to erase this in a minute, so you don't need to write it down. But what's very important is don't tell me your center is negative 2, 1. Even though that's the way it's written here, negative 2, 1. Remember, your h or your x coordinate is always with the x, and your y coordinate is always with the y. So the center for what I've got written up here would be 1, negative 2, not negative 2, 1. So just, it didn't matter on this one because it's 0 and 0, but just be aware for that. Don't do that backwards. All right. Now, I don't care that this number is bigger. This is not an ellipse. If this was an ellipse, I would say, oh, this is the bigger number, so my vertices are 5 units in the x direction. But it's not an ellipse. It's a hyperbola. Now, I look at which number is in front of the minus sign, or positive. So my vertices are, this is a squared, so I'm going to go 3 units, square root of 9, in the y direction, that's up and down. And that's how I'm going to get my vertices. So 0, 0 is my center, 3 units up, 3 units down. And those are my vertices. So my vertices are 0, 3, and 0, negative 3. Now, we don't have co-vertices, but what we do have are these asymptotes. And if you read the directions up there, it tells you you can make a box. If I had co-vertices, there would be 5 units left and right. 5 units left and right. And what I'm going to do, I'm going to make this box. I'm going to go 5 units left and right from my vertices, or from your center. It doesn't matter how you think about it. We just need to go over 5, left and right. So 5 units left and right, if I line up with my vertex, would be here and here. Well, what these are the corners of the box, here and here. So you don't have to draw the box, but I just want you to kind of see that rectangle that we got going on right there. 5 right, 5 left. Your asymptotes go through the center of that box and through the corners of that box, the diagonals of the box. And that tells you how wide to make your hyperbola. When you go to draw your hyperbola, you have to go through your vertex and you have to approach your asymptotes. That's why if this was a steeper line, say like this, it would be a more narrow hyperbola. You have to approach. So on this one, we're going to go vertex, approach, approach. Don't curl them back inward. They basically, they're not like a parabola. Parabolas would curve and start becoming like straight up and down. These actually follow this line, and they become straight lines on their edges. And that's the hyperbola. The last thing we need to do is find the focus. We have a new formula for c squared. It's now a squared plus b squared. So that would be 9 plus 25, which is 34. So c is the square root of 34, which is, it doesn't simplify, it's just some decimal. They're always in the same direction as your vertices, so up and down. So it would be, take our center, travel up and down from 0, square root of 34, and you get that equation of your points for your vertices. The very last thing is writing those asymptotes. When your center is 0, 0, it's actually really easy because they go through the point 0, 0. So your y-intercept is 0. You just need to think about what your slope is. Remember, rise over run. We went up 3 and over 5 because we went through the corners. So this line is 3/5 x because your y-intercept is 0. This line is just negative 3/5 x. And you get the equation of your asymptotes. All right, moving on to number 2. Number 2 will be a little more, or 1b, whatever, will be a little more complicated because our center's being moved. Now this time I notice that x is in front. Remember, I don't care about which number is bigger. I care about what's positive or which letter is in front of the minus sign. So this is a left-right or a horizontal hyperbola. My center is at -1, -2, and this is what I was talking about. If these are switched, then this would have been my x and this would have been my y, if the x and the y would have been switched. So be careful with that. I'm sorry, let me go back to this one for a minute. I didn't graph my foci, just to make sure you know where they would be. If you type square root of 34 in your calculator, you get 5.8. Make sure you realize they are on the same axis as your vertices. They're inside the hyperbolas. So this, remember, was up 3. If I need to go up 5.8, I got to go 3, 4, 5.8, about right here. And then down 3, 4, 5.8. They're always inside the hyperbola, the branches. All right, back to this one. So my vertices now, I go 3 units left and right for my vertices, 3 units left and right for my vertices. 1, 2, 3. That lands me at 2, -2. I could have just added 3 to that number, and you get 2. 1, 2, 3, -4, -2. Once again, I could just subtract 3 from that x coordinate. All right, my box now needs to be 4 units up and down, 4 units tall up and down. These are my vertices here. 1, 2, 3, 4. These are the corners of the box. Remember that. 1, 1, 2, 3, 4, corner, 1, 2, 3, 4, corner, and corner. So you kind of get this box, and you don't have to totally draw it in. Just realize that those corners, the center and the corners, the diagonals, make your asymptotes. And that tells you how to, the width. We don't have a lattice rectum like in parabolas. We have these asymptotes. And that's drawing it. That's really all I need you to do for drawing it. We need to make sure we know how to find our foci. C squared is 16 plus 9, that's 27. C would be the square root of 27. Always in the same direction of your vertices, since my vertices went left and right. Then I would make my foci left and right. That means they affect the x-coordinate. So it would be -1 plus or minus, the square root of 27 can reduce. 3 square root of 3. This is 9 times 3. Square root would be 3 square root of 3. The y-coordinate doesn't change. All right, and square root of 27 is 5 point something. So from your center, 5 point something, 1, 2, 3, 4, 5, and a little more. And 1, 2, 3, 4, 5, and a little more. All right, finding the equations of the asymptote for this problem is probably the hardest part. So we're going through the point -1, -2, that's our point. And the positive slope line is going rise 4, run 3. Make sure this is your rise because it's under y, and this is your run because it's under x. So my slope is 4/3. So now I'm writing the equation of a line. I'm going to do point slope formula, where I do y minus the y-coordinate equals slope times x minus the x-coordinate. Notice this right here is just that right there, and this right here is just that right there. And that always works out that way. That's the point slope formula is just another formation of like the distance formula. It's just rearranging all of that stuff for different values. So I distribute my 4/3, and then I got to subtract 2, but I need a common denominator, so in my head I'm going to switch that to 6/3, which is 2, like terms, and I get 4/3 x minus 2/3. Now that's only one of my asymptotes. I have another one. It's going to work out similar, but yet it's going to be a little different. For my other one, I'm going through the same point, the center, except my slope is -4/3 instead of +4/3. Starts off the same, y plus 2, just this time it equals -4/3 times x plus 1. Distribute, becomes x minus 4/3. And I want to subtract 2 again, but with a common denominator, that would be 6/3. And my second equation, 4 minus 6, 10, -10/3. So that was a little harder. That's about the, what makes hyperbolas a little harder are the equations of those asymptotes. Don't forget, though, when they're centered at 0, 0, they're actually really easy. You just do positive, negative slope. It's when the center is shifted off of 0, 0, they become a little more complicated. All right. Next example, what is the center? What is the direction, left, right, or up, down? I know that because x squared, x is in front of the minus or is positive. What are your vertices? Two units, left, right. What is the slope of your asymptotes? Rise over run, up 1 over 2. The height of your box is 1. Tiny, tiny little rectangle right here with very narrow diagonals, making this a very narrow hyperbola. For your foci, you need to find c squared, or c, which is c squared is 4 plus 1. So c is the square root of 5, left and right. So what are the ordered pairs? That square root of 5 affects your x-coordinate of your vertex. And then because we're centered at 0, 0, again, your asymptotes are actually pretty easy. Go ahead and find your asymptotes. It's that rise over the run, x, and that's hyperbolas. Last example, you can go ahead and finish that one on your own. Thank you.